Hello, Dr. Foggybottom. I came to see you about the nomenclature assignment.
Yes, how can I help you?
I am confused about the 3 rules for naming.
The rules depend on whether the compound contains a metal or not. If there is a metal present, you use type 1 or type 2 naming. And if you do not have a metal at all, you use type 3 naming.
What do you mean by metal?
Metals are the elements that can be found on the left side of the periodic table. The main group metals, group 1A, 2A, and some from group 3A, or groups 1, 2, 13, will follow type 1 naming because they will always have the same charge.
The same charge? Do you mean that the alkali metals from group 1 always form a single positive charge?
Yes, that is correct, and the metals in group 2, the alkaline earth metals, will always form 2 positive charges. So, those metals will always use type 1 naming, and I will explain how this works later.
Okay, I kind of understand what metals use type 1 naming, but what about type 2?
Type 2 is used for metals that do not always form the same charge. You can find this in the transition metals. Transition metals can be found in the B groups, or groups 3 through 12.
Alright, so you explained to me that the metals use type 1 and type 2 naming. Where do you find type 3?
Type 3 is done by elements that are not metal at all. If you look behind me, the non-metal elements are in the boxes with a lime green background and the halogens with a turquoise background. You only find type 3 naming between elements from main groups 4A to 8A, or groups 14 to 18.
Doctor, let me recap now. Type 1 is for main group metals.
Yes, metals like the alkali and alkaline earth metals.
Type 2 is used for transition metals.
Yes, elements such as zinc or iron use type 2 naming.
And type 3 is used by non-metals only?
Correct. A good example for type 3 naming is carbon dioxide. Notice, this compound is only made up of carbon and oxygen. Both are non-metals.
Now, please tell me what is special about each of these rules.
Well, there's nothing really special about type 1 naming. In this naming you just use the regular element names for the metal component and the proper name for the anion part. An example is sodium chloride. Sodium belongs to the group 1 main metals, and chlorine gets changed to the chloride and ion. Then you simply combine the 2 names.
What about type 2 naming?
Type 2 naming is a little bit more complicated, but just a little. Because the metals that follow this rule can have more than one charge, you have to include the charge information as part of the name in the form of a Roman numeral. Remember, the metals here are the transition metals. Therefore, if you have iron with 2 positive charges, you would use iron 2, and for the anion, you just simply use the anion name, just as I explained earlier. An example is iron 2 chloride. And if you have iron with 3 positive charges, then you use iron 3 and add the anion name, like iron 3 chloride.
Doctor, that leaves us with type 3. What is special about that?
Well, as I already mentioned, type 3 is made up of elements that are not metal and they are not ionic. They are actually covalent compounds, and if you do my worksheet, you will notice that the components to these compounds do not have any ions listed. Because you do not have charges, you have to somehow indicate in the compound name how many particles/atoms of each element are in it. This is accomplished by using a prefix for both elements in the compound.
You mentioned carbon dioxide as an example earlier.
Yes, in carbon dioxide you have 1 carbon and 2 oxygen atoms. Because you have 2 oxygen atoms, you use the prefix di.
Can you give me another example?
Yes, how about if you have N2O4, a compound that has 2 nitrogen and 4 oxygen?
I think I would need to use the prefix di for the 2 nitrogen and the prefix tetra for the 4 oxygen.
Yes, the compound would be called dinitrogen tetraoxide. Great job.
Doctor, so far you have mostly talked about the cation, or metal part. How do I name the other part?
That, my dear, is relatively simple. For simple ions, you usually change the ending to "ide." So, you end up with a chloride compound.
Can you please give me another example?
Sure, how about oxygen? How do you think the name will change for it?
I think you would need to use oxide. Like you mentioned for carbon dioxide.
Yes, correct.
This is easy. What about these complicated ions? I think you called them polyatomic ions.
Yes, take a look behind me. Here is a list of many of the polyatomic ions and their names. Look at NO2 with one negative charge, that is called the nitrite ion, and if you combine it with a metal, such as potassium, you end up with potassium nitrite.
That sounds pretty easy. How about another example?
Sure. Try to find the name for PaO4 with three negative charges.
Is that the phosphate ion?
Yes, that is correct. I think you got it now. And if you combine it with a metal, like calcium, you end up with calcium phosphate. Super work. This concludes our short tutorial on how to name inorganic binary compounds. Hope to see you for the follow-up on how to make inorganic binary compounds.